Use Pascal's triangle to expand 2 minus 3x all to the power of 4. Now, since the index of this binomial is 4, we'll need to refer to row number 4 from Pascal's triangle to help us determine the coefficients of the terms of the expansion. But before we do that, let's consider the expansion of a plus b all to the power of 4. Pascal's triangle will give us the coefficients of the terms of this fundamental expansion. So a plus b all to the power of 4 is equal to a to the power of 4 plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the power of 4. Something else worth noting is that each of the terms of this expansion, the sum of the powers of the variables equals the index of the binomial itself. So we have a to the power of 4, so 4 equals 4. 4a cubed b to the power of 1, so 3 and 1 gives us 4. 2 and 2 gives us 4. 1 and 3 gives us 4, and of course there's b to the power of 4 on its own there, and 4 and 4 obviously are identical. And the coefficients, we've got one lot of a to the power of 4, and we've got a 4, 6, 4, and 1 lot of b to the power of 4, and they come directly from row 4 from Pascal's triangle, so 1, 4, 6, 4, 1. Next, we can substitute values for a and b. Now, in this case, a equals 2, so that's this term here, and b equals negative 3x, so that's the second term of the binomial. So we'll substitute these two values for a and b in this expansion, and then just evaluate it and simplify it. So when we let a equal 2 and b equal negative 3x, we obtain 2 to the power of 4 plus 4 lots of 2 cubed times negative 3x plus 6 times 2 squared times negative 3x all squared. So it's very important that the negative term especially is in brackets, plus 4 times 2 times negative 3x all cubed plus negative 3x all to the power of 4. So 2 to the power of 4 is 16. 4 times 2 cubed times negative 3x is negative 96x. 6 times 2 squared times negative 3x all squared is positive 216x squared. 4 times 2 times negative 3x all cubed is equal to negative 216x cubed plus 81x to the power of 4, so that's negative 3 all to the power of 4 is positive 81, and of course x to the power of 4 is x to the power of 4. Use Pascal's triangle to expand 5x plus 1/5 y, all raised to the power of 5. Like the previous example, let's start off with the expansion of a plus b to the power of 5. So this is a fundamental expansion. The coefficients of the terms of this expansion come from row 5 of Pascal's triangle. So we have 1, 5, 10, 10, 5, 1. So the expansion, following the pattern that we've already observed, is 1 lot of a to the power of 5 plus 5 a to the power of 4 times b plus 10 a cubed b squared plus 10 a squared b cubed plus 5ab to the power of 4 plus b to the power of 5. Now a equals 5x from the original binomial and b equals y over 5. So rather than writing it as 1/5 y, it's just a little bit easier to write it as y over 5. So substituting in 5x for a and y over 5 for b in the right hand side of this equation, or this identity, we obtain 5x to the power of 5, or all raised to the power of 5, plus 5 times 5x to the power of 4 times y over 5, plus 10 times 5x, all raised to the power of 3, times y over 5 to the power of 2, plus 10 times 5x all squared times y over 5 all raised to the power of 3, plus 5 times 5x times y over 5 to the power of 4, plus y over 5 all raised to the power of 5. So simplifying this expression here, so 5x to the power of 5 is 3,125x to the power of 5 plus 625x to the power of 4 times y. So that's 5 times 5 to the power of 4 divided by 5. So you can cancel this 5 with this 5 here. So we just have 5 to the power of 4. That gives us 625. Then we have 10 times 5 cubed divided by 5 squared. So that's the same as 10 times 5, which is 50. And so likewise, we have a similar thing going on here. So 10 times 5 squared divided by 5 cubed So it's 10 divided by 5, so that gives us 2. And we have 5 times 5 divided by 5 to the power of 4, and that gives us this coefficient here, 1 over 25, times x y to the power of 4, so that's x and then y to the power of 4, plus y to the power of 5 divided by 5 to the power of 5, which is 1 over 3,125 multiplied by y to the power of 5. Find the term independent of x in the expansion of 2x plus x to the power of negative 2, all raised to the power of 6. Now, the term independent of x refers to a term of the expansion that does not involve the x variable at all, so it'll just be a constant. So, like the previous examples, let's consider the expansion of a plus b to the power of 6, and the coefficients of the terms of this expansion come from row 6 of Pascal's triangle, so 1, 6, 15, 20, 15, 6, and 1. So a plus b, all raised to the power of 6, equals a to the power of 6 plus 6, a to the power of 5b, plus 15, a to the power of 4b squared, plus 20, a cubed, b cubed, plus 15, a squared, b to the power of 4, plus 6ab to the power of 5, plus b to the power of 6. And from the original binomial, we have values for a and b. So a equals 2x and b equals x to the power of negative 2. So substituting those two values into the right-hand side of this expansion, we have 2x all raised to the power of 6 plus 6 multiplied by 2x to the power of 5 multiplied by x to the power of negative 2 plus 15 times 2x all raised to the power of 4 times x to the power of negative 2 all raised to the power of 2. Now at this point, I'm going to stop. There's no point, in fact, going any further because I can see what's going to happen now. In this particular term, the x terms will in fact cancel. So I'm just going to elaborate on this particular term here. You'll see why shortly. We have 15 multiplied by 2x all raised to the power of 4. So that's 15 times 2x all raised to the power of 4 multiplied by x to the power of negative 2 all raised to the power of 2. So x to the power of negative 2 all squared. And that equals 15 multiplied by 16 multiplied by x to the power of 4. So that's x to the power of 4 here multiplied by x to the power of negative 4. So this is using the power to a power rule. Negative 2 times 2 is negative 4. And simplifying that, of course, so we have 15 times 16 times x to the power of 0. So when multiplying two terms with the same base, you add the indices. So 4 plus negative 4 is equal to 0. Then 15 times 16 is equal to 240. And x to the power of 0, we just treat that as 1. So the term independent of x, in fact, is 240. Find the term in x squared of the expression 5 plus x in brackets times 2 minus 3x in brackets raised to the power of 7. The strategy here is to consider the expansion of 2 minus 3x to the power of 7. And we're going to consider that as far as x squared. And then consider the product of that expansion with the binomial 5 plus x. And that expansion will result in terms in x squared, and we collect the like terms, and there's our answer. So expanding 2 minus 3x to the power of 7 as far as x squared, we'll need row 7 from Pascal's triangle. So we'll need the first three terms here, so 1, 7, and 21. So expanding that as far as x squared, we have 2 to the power of 7 plus 7 times 2 to the power of 6 times negative 3x plus 21 times 2 to the power of 5 times negative 3x all squared plus dot dot dot. Again, no need to go any further than that. And that equals 128 minus 1,344x plus 6,048x squared minus dot dot dot. Again, no need to go any further than that. Now we'll consider this expansion multiplied by the binomial 5 plus x. So 5 plus x in brackets multiplied by the expansion 128 minus 1,344x plus 6,048x squared minus dot dot dot. And we're looking for terms in x squared. And there's two ways that we can obtain that in this particular product. We can either take the x term in the first binomial, or in this binomial, this one's not a binomial obviously, but we'll take the x in the first set of brackets, multiply it by negative 1,344x, and that gives us our first term in x squared. And another way to obtain a term in x squared is to take this 5 here and then multiply it by 6048 x squared here. So we end up with negative 1344 x squared plus 30,240 x squared. Of course, they're like terms, we can combine those, and that equals 28,896 x squared.